All right, good morning. So, every year, conference season lines up when Apple releases their new operating systems, and I'm a total Apple fanboy, so I'm like, yeah, I want to upgrade, but I also yeah, my slides have to keep working. So it's a bit of a bummer, but this year, Apple announced the iPad Pro, and I was pretty excited because I thought like maybe this year, finally with OS 9, it's ready for me to build a presentation in. So this talk's built entirely in OS 9. So let's start. So I'm just booting up here. All right, it's a little retro, it's a little slow. Okay, so I'm going to open up my presentations in this thing called AppleWorks. All right, here it is. Great, got to find the play button. Okay, cool. Here we go. This talk's called How to Stop Hating Your Tests. My name is Justin. I play a dude named Searls on the internet. I'd love if you go find me. I work at the best software agency in the world, Test Double. When I say, hey, why do people hate their tests? Well, usually we start off in this fun, exploratory, experimental phase where we're just building stuff. We don't need automated tests because it doesn't have to work, and tests would just slow us down, slow down our rate of change. But eventually we get to a point where we want to be careful when we push, we don't break shit. So we write some tests, we push them up, we make sure that our build keeps working. But most teams do this in a kind of haphazard, one-off way, so we end up with like a lot of spaghetti. We end up with haphazard tests that are all inconsistent and really slow, and that leads to frustration. People longing for the days of like when they could just write code, make stuff work, instead of have to do all this test cleanup all the time. And I see this pattern enough as a consultant on so many teams that I feel like an ounce of prevention is worth a pound of cure at this point. Because once you get to the end, there's not much you can do. You can say like, well, our test approach isn't working, so maybe we just aren't testing hard enough. And I think the approach of like, work harder, comrade, is not effective when we keep seeing the same problem come up, right? Like we can improve our workflow, we can improve our tools. So some people at this point, they'll say, hey, testing is job one. Let's just buckle down and remediate for a few months and then get back to square one. But from the perspective of the people paying us, testing isn't job one. It's at best job two. From their perspective, shipping is job one. They want to see you get features out the door. And the longer that you go off the reservation, the more friction is going to come up. Finally, if you're not greenfield, like if you've got a big legacy app right now and I'm talking about prevention, don't worry, it's not a problem. This applies to you too, because there's this one weird trick to starting fresh with testing. That's right, you're going to find out what the one weird trick is. Basically, you can just move your test directory into a new directory, create another directory, and then get two directories. And you can write a thing called a shell script, and you can make CI run both of those test suites until you can decommission the old shitty tests. Don't trust me though, I'm an expert. I'm the worst kind of expert. I've got lots of navel-gazing experience, many open source projects, been on a lot of different teams, and I've gotten in way too many philosophical Twitter spats over testing stuff. My advice really is just toxic at this point. It's this hell stew of cynicism, negativity, risk aversion, and I don't want to just blast that at you. So instead I'm going to distill some of that down into just 3 component parts. I'm going to talk about test structure, physical, like what our like listings look like and our directory layouts and so forth. I'm going to talk about isolation, because the best way to communicate the value that we hope to get out of our test is what we choose to isolate it from, what we're testing. And feedback, like what's it like? Does it make us happy or sad to live with our tests? Are they fast, are they slow, that sort of thing. My brother picked up this, found this old Apple II floppy of Family Feud, and because it's really hard to do custom artwork in AppleWorks, it turns out, we just ripped off that. So we're going to show everything today up on this board. That means if I say like, hey, show me potato salad, I get an X. But unfortunately, I didn't have 100 people to survey. I just surveyed myself 100 times, so I know all the answers already. So we're going to first round, we're going to talk about the test structure stuff. And I'm going to say, show me too big to fail, because people really hate testing big objects. And in fact, have you ever noticed that people who are really into TDD and testing, they seem to really hate big objects, big functions more than other people? And granted, we can all understand having a big thing of code is hard to deal with. But actually, writing tests of those big dollops of code makes managing those objects even harder. In some ways it's straightforward, right? Like big objects have a lot of dependencies, so the tests have a lot of tests set up. Big objects have usually a lot of side effects in addition to whatever they return, so the tests have numerous verifications to make. But most importantly, big objects have a lot of branching, either based on inputs or based on state. And so that means we have many different test cases to write. And that's what I want to highlight, because that is what has the really delirious effect on our test suites. So at this point, let's take a look at some code. Unfortunately, OS 9 doesn't have a terminal or Unix, so I had to go and drum one up somewhere. So I'm going to open up here this Unix terminal. I know it's tiny, but basically in this test here, I'm writing a validation method. of whether or not somebody enters notes into their timesheet, and whether you have to enter notes or not depends on if you're an admin, if it's an invoice week or an off week, if you've entered any time, and there's 4 booleans that go into it, and I realized, damn, that's a lot of different contexts that I have to concern myself with. What I fell victim to there is a rule of product. It's a rule from combinatorics, the field of math. You know it's a real thing because it has a Wikipedia page. And what it says is essentially, if you've got 4 variables and you multiply all of the various number of possible values for each of those variables, that'll give you the upper bound of combinations, or in this case, the upper bound on the number of test cases you might have to write. So in this case, we've got 4 Boolean variables. It's actually the best case scenario, so we only have 2 to the 4th, 16 test cases possible to write for this one little method. And so when you're used to being on a team writing a lot of big objects and big methods, you might say, well, I'll just add one more little argument to that method and effectively double the number of tests that I have to write. So that's one reason why testing actually makes big objects harder to deal with when we assume the opposite. Our intuition betrays us. I encourage most teams, stop the bleeding. If you've got a lot of big objects and you also want to write a lot of tests, don't keep adding to your functions and your methods. Start building new stuff. In fact, I try to limit every new module I write to just 1 public function and at most 3 dependencies to just decrease the tangling and have small things. People react really sharply to this. They're like, we'll have too many small things. How on earth will we deal with all these well-organized and carefully named and comprehensible small things? It's like programming on easy mode. That's not what professionals do. And I'm like, it is easy. It's really just way better to live that way. In fact, it does compose well because you put a lot of thought into it. So just do that. Second thing I want to talk about is people hate tests when they go off script. Code is awesome because code can do anything. Our programs can be as creative and as unique as we like, but tests can only really do 3 things. They all follow the exact same script. Every test ever sets stuff up, invokes a thing, and verifies behavior. Some people call these the 3 phases, arrange, act, and assert. I think it's a little bit more natural language to call them given, when, and then. And in my tests, I always call out all 3 of these phases really, really clearly so that when I'm skimming, I can see what phase I'm in, and I always go in order. Like in this test here, I've got kind of an XUnit style, one big block of code. All I'll do in this test is just add significant white space between the 3 phases. The only new lines I add are separating arrange, act, and assert, just as a little tiny trick. Or, in the same test, if I'm doing a more BDD style, I can pull up all of those setup methods into a before block, so they're very clearly set up. And I'll still use a significant white space here for that action. So the blog add comment is also in the before, but it lets me split up my assertions into separate if statements. So just anyone glancing at that knows what's set up, knows what the action is, and knows what the assertions are. I also try to minimize each phase to just 1 line per action to try to guard against too much test scope logic leaking into my tests. The late, great Jim Weirich, an awesome Rubyist, built this RSpec given gem that really blew my mind at the time. I ported it several years ago to Jasmine for JavaScript testing. Since then, we've got 2 different ports to Mocha. And what it does, so I converted this test to CoffeeScript because as a testing DSL, I like CoffeeScript a lot when I'm using Jasmine given or Mocha given. And here's what it looks like to convert it. So instead of a before block, you just can fit everything into the phase that it belongs. So I've got several given functions setting up my variables. And then that action I'm taking, I can just put into a when function. And then the assertions, they use natural assertions. So it's actually able to interpret both sides of every comparison that it detects to give you nice error messages. It's very, very terse, but still just as nestable as any other. Tests that are conscious of these 3 phases are easier to read. They point out superfluous code when it doesn't fit one of those buckets, and they can highlight certain test design smells. For instance, if you have a lot of given steps, maybe there's just too many dependencies, or your arguments are too complicated. Whenever you need more than 1 when step, it usually means the API is not user-friendly enough. You should just be able to invoke the code that's under test. And if you've got a lot of then steps, then maybe the code's doing too much. Maybe it's got side effects as well as returning something. Next thing I want to talk about is hard to read, hard to skim code, because a lot of people are fond of saying, test code is code, take it seriously, but test code is untested code, so treat it with cynicism and skepticism. In particular, logic in tests, normally when I read a test, I'm trying to learn the story of the code that it's describing, but if there's logic in the test, now I'm focused on understanding the logic in that test and understanding it's not tested. And test scope logic isn't just hard to read, but if there are any errors in it, it's very easy to miss them. Maybe it's passing for fantasy nonsense reasons, we don't know. So people often ask me, especially when I'm doing training on testing, they're like, hey, well, I can really dry up this test by generating my test cases. For example, this fella has a whole bunch of Roman numeral 2 Arabic assertions, like 14 of them all in a row. And so it's really tempting to him to salve the pain of all that repetition by just looping over a data structure and then for each of those pairs, generating a new test case. And there's nothing technically wrong with this. It works. It actually improves the error messages in this case. The problem is that whenever I experience a pain in my test, I pause and I first blame my production code. I think maybe there's something about my production code and my API design that's making this test hard to write, instead of thinking I'm going to immediately salve this test pain. Because if you looked at this person's actual production code, you can see all of that data is hiding in if and else logical branches inside of that code. That data is still there, so why not pull the data out in the production code? You can build exactly the same map. You can eliminate all those if and else branches, and now the function is actually much more comprehensible and simple. Granted, the variable names aren't all that great, but it means I can just keep adding additional keys to that data structure, and I don't need every single test case in the entire world to cover it. Lastly, on test structure, I want to talk about accidentally creative tests, because they're another reason people hate their tests. I believe strongly that consistency is worth its weight in gold in testing. For example, this test here is setting up a few things, author, blog, comment, but I can't see at a glance what is the thing being tested. So I always name the thing being tested subject. Subject is not a meaningful word, but I name it that anyway. And I always name the thing that's being asserted on, or whatever I get back from my subject, result or results. That way, if a test gets big, I can just at a glance see that's the thing being tested, every single time. And when everything's consistent, the inconsistency in our tests can have meaning. For example, if most of the tests look the same, but oh, wait a second, test C there looks a little bit different, that's a cue to me as a reader to say, maybe there's something interesting about function or module C. Let's look into that. But most people's tests are so inconsistent that you have to take that same level of scrutiny to every single individual test and treat it like its own unique snowflake, which really slows down reading comprehension. And as a result, me personally, I would much rather adopt a code base of hundreds of very mediocre or even crappy but consistent tests, because I can improve them all at once and understand them all at once, than a handful of artisanal, beautifully crafted, really creative, brilliant tests. Always prefer the thing on the left. Also, readers have this silly habit. They assume that all of our code has meaning. In fact, in test code, you're probably familiar, like a lot of our code is just plumbing to make the thing invocable and be able to assert an outcome. So I try to point out meaningless things just to help my reader out whenever possible. So you can make unimportant test code look obviously meaningless to the reader. If you look at this test here, we've got a very realistic author getting instantiated with a realistic name, a phone number, and a valid email address. But maybe that doesn't matter for this function. So like, for example, maybe the author doesn't need a phone number, and maybe any string will work. So I'll just name him Pants, and then his email's pantsmail. And now I look at the assert, and I update the assert as well. And so now anyone reading this test isn't going to be under any delusion that that this function does any more than just interpolate this string. Whereas before you might think, why does he have to have a valid email address? Maybe it's validating. This is way easier. So when test data is minimal and minimally meaningful, it prevents your reader of that test from possibly getting stuck in some rabbit hole, assuming that it's very important. All right, so congratulations. We just talked a lot about test structure. Let's move on to the second round, talking about isolation in testing. First thing I want to talk about is unfocused test suites. So when people define success on their teams with respect to testing, the most important metric to them is usually just, is it tested? And then yes is the right answer, and then they're happy. And that's all they really care about in terms of evaluating whether their test suite is good or not. But I'm much more concerned on mature teams asking, is the purpose of each test readily apparent, and does its test suite promote consistency? And I very rarely am able to answer yes to that question on most teams, which raises an interesting reaction from people saying, hey, how can I make everything consistent? I've got to test for all these different types of cases, got all these kinds of tests in my test suite. My answer to that is, you can actually make, just like you can make 2 directories of tests, you can make as many test suites as you like. So define the 4 or 5 types of tests that are important to you, and create a separate suite with its own conventions and norms for each of those types of tests. I actually did a whole talk just on this called Breaking Up with Your Test Suite. There's a short URL there. There's a thing in Agile land called the testing pyramid, and it's a way to illustrate stuff at the top of the pyramid is a more integrated type of test, and stuff at the bottom of the pyramid is a less integrated test. Most test suites that I see on various teams, one big test suite will have some tests that call through to other units, some tests where they'll fake out the relationship with other units, some tests where they maybe hit the database but they fake out third-party APIs, and then other tests still will actually hit those third-party APIs but they'll operate beneath the user interface. And me coming into the test suite now, I have to read every single test very carefully to understand, okay, what's being faked here? What's under control? What's being tested? What's the value of this test? All of that is determined by what you're faking and what's left is real. encourage teams start with exactly 2 test suites, each approaching one of those extremes. So that means one test suite should be as integrated as we can possibly manage, and the other test suite should be as isolated as possible. That way when you're writing a test, the answer to the question, should I fake this or not, is intuitive. The tests at the bottom, they just make sure that every single individual listing of code does exactly what that listing of code says that it should do. And the tests at the top simply make sure that when you plug all those little units together, nothing blows up. It's just your safety net. And it's possible that the need will arise to have some sort of intermediate test suite to cover some edge cases in a semi-integrated state. And that's fine too. For example, on an Ember team recently, we decided we're going to write component tests in this sort of middle layer, but we had to be very careful to agree to a set of conventions and norms. For instance, we just said arbitrarily, we're going to fake all the APIs, we're going to not use any test double objects, we're going to trigger actions, not user interface events, and we're going to verify app state, not HTML templates. These were arbitrary decisions, but by deciding them up front, we're able to make sure that every test in that suite is super duper consistent. And I wrote a whole bunch of test helpers to help enforce that consistency. Next, because I talked a little about test doubles, we're just going to talk about, see, I said I knew this stuff and I didn't. Show me too realistic. Okay, well, we're going to talk about something. Too realistic. So, if you ask the question, how realistic should tests be? Most people will say, well, as realistic as possible. I want to make sure my stuff works. And so they might be really proud of the fact that they got a browser, talking to a server, talking to a database, and they think that's maximally realistic. There's no holds barred. But then I'll come and poke at it. I'll say, well, does it talk to your production DNS? Does it do DNS resolution? They're like, well, no. Well, does it test against your CDN? Does it verify that your cache validation strategy works? And they say, well, no. So in fact, there is a boundary. It's just implicit. They have decided to control for certain things, but they haven't really thought too hard about it. That means if something ever blows up in production, it's totally fair for somebody else on the team to be like, hey, why didn't we write a test for that? No one else can say why not, so they just get stuck in this trap where they write some tests, something will blow up in production, and then when it does, the whole team just has a come to Jesus moment where they're like, why? And their only reaction is to shout, never again, and then they increase the realism on all their tests, making them more and more integrated. Now the problem with that is that realistic tests are slower. They take more time to write, to change, to debug. They represent higher cognitive load because you have to have more and more in your head to make sure that everything's working. And they fail for more reasons because there's so many moving parts. Realistic tests are much, much more expensive. So I insist that people will establish very clear boundaries to increase the focus on what they're testing as well as what they're controlling. And with clear boundaries in mind, same team writes tests. No amount of tests is going to prevent stuff from blowing up in production once in a while, so it happens. But now the team can stand up. They've got a backbone. They're able to respond and say, look, we talked up front about how that type of testing would be too expensive to do across all of our tests. We weren't able to predict this, or we didn't anticipate this production failure, and it's really hard to automate stuff you can't predict. So we probably wouldn't have written the test anyway. And finally, we can write a targeted test for just this concern off in the corner. We don't have to make our entire test suite more slow, more complex in response to this problem. Aside from having a high cost, realism in and of itself isn't some kind of virtue to uphold with testing because less integrated tests offer more design feedback. And they're much easier to fix because the error messages are much closer. They can tell us more about our object design. Now we get to talk about test doubles because a lot of people hate their tests because of over-mocking or careless mocking objects. If you're not familiar with the phrase test double is like a stunt double for your tests. It's anything that stands in for a real thing for the purpose of your test. It could be a fake object or a function that you hand roll. It could be a stub, a mock, a spy. Maybe you do it on your own. Maybe use a library. What's funny, of course, is that I actually own a company called Test Double, and we maintain several open source Test Double libraries as well. In fact, most recently, I've been spending my free time building a thing called Test Double JS, which, in my opinion, has quickly become the best mocking library for JavaScript, whether it's in the web or Node. I strongly urge you to go npm install Test Double and check it out. I just had to squat on the name, so I'm like, well, I'm guessing now I'm going to make a library. So when I meet people at conferences, they're like, well, I guess that means you're pretty pro-mocking. And it's actually a lot more complicated than that because how I use test doubles is very nuanced and careful. If I want to test drive a new subject and I think it's going to have these 3 dependencies, I'll start with a test of the subject and I'll fake those 3 things out. And then my test is like a sounding board. I'm listening for any awkwardness in the contract between the subject and those fake things. And because those fake things don't exist yet, it's very cheap for me to iterate on the design of those APIs. That's how I use test doubles. I did a nice 4-hour free screencast on what I call discovery testing, my approach to using test doubles in TDD. That's up on that short URL. It's at Test Doubles blog if you can't write that down. But 99% of the world, what they do is they pull down sign-on or they pull down, they use Jasmine spies or something, and they only use them as this cudgel to make it more convenient to write otherwise hard to test codes tests. So like if they've got a similar sort of situation, something with 3 dependencies, and some of those dependencies are happy, and some are frustrating to work with, and they can't make their test work, they'll just use a test double, they'll use a mock object or something, mock out those annoying things, and just to shut them up to get their test passing. And this sucks because it treats the symptom of the test pain, but not the root cause, which is an awkward relationship between some subject and its dependencies, greatly confusing future readers who are going to be like, what's the value of this test? Is it really testing anything? Like, some stuff's real, some stuff fake. Some people actually mock out stuff on the thing that they're testing. It's crazy. And it makes me really sad because it gives mock objects, it gives test doubles a bad name, and I got to protect my brand, y'all. So if you see someone abuse a test double, please say something. Hashtag mock your mocks. So that was a little bit about test isolation. Congratulations, we're 2/3 of the way through this thing. Let's talk a little bit about test feedback. First thing I want to talk about is useless error messages. Okay, so let's get started. Ah, shit, I broke the build. So now what? So here's my test. It says assert OK. It says Sterling Archer equals user full name. It's a real straightforward, just string comparison test. And so I'm going to run the test here. When I run the test, I look at the assertion. I'm like, oh, wait. Expected actual false true. That's a totally worthless error message. That doesn't tell me anything at all. And my workflow in this particular case is I see the failure. Now I have to go read the test and probably put in a print statement or start debugging to figure out what the actual value is. Then I can change the code so that I can see it pass. But by then I need to take a break because 20 minutes have elapsed. And every time I get an unexpected failure, this is my workflow. That's no good. So we'll often pride ourselves on how fast our test suite are, but having an assertion library that gives you bad messages just adds tons of friction to your workflow. Instead, and I realize this is kind of tiny, but this is using Jasmine given, just as then Sterling Archer equals user.fullname. Running the same kind of test, I get much better error messages. Here it says, expected Sterling Archer to strictly equal Sterling Mallory Archer. That was the problem. And it shows me exactly what the comparison detected was. So test failure workflow in this case, I see the failure, I change the code, and I was so fast I earned a big juicy promotion. Strongly urge everyone to judge assertion libraries, not just on Chai's really cool little dot syntax, but rather on the message quality of the API itself. Most people don't look at this until it's too late and they're saddled with an expectation library that isn't really good at it. Next up I want to talk about slow loops, about feedback loops, about productivity. Anyone know what this number is? What's significant about 480? It's the number of minutes in an 8-hour workday. And I think about this number a lot when I'm analyzing my productivity. If I am thinking in terms of feedback loops and say maybe it takes me 15 seconds to make a change to my code and 5 seconds to run a test of wall time, and it takes me 10 seconds to decide my next action, that's a 30-second feedback loop, which gives me an upper bound of actions, of thoughts or experiments per day of 960 actions. Now, in real life, I've got a lot of non-code responsibilities, as well as context switching costs, and in a 60-second feedback loop, this would allow for 2 hours of non-code activity every day. So, in that case, like I said, 480 minutes in a day. Now, assume that our tests are maybe a little bit too integrated, or we got a crazy gulp or grunt build, and we can't run just one test in 5 seconds. Maybe it takes 30 seconds. Now we're looking at a 91-second feedback loop, which takes a third of our actions a day. Now we have a third fewer thoughts in a workday. Assuming you got really bad error messages, like we just saw, maybe it takes you, instead of 10 seconds to figure out what to do next, 60 seconds, because you got to interpret what just happened after you run the test. And so now we're looking at a 2.5-minute long feedback loop, which now we only have 185 actions a day. Maybe your team has some integration tests, like Selenium stuff that goes and automates a browser. And running that suite is really challenging, and to run a test takes you 4 minutes. I've been on teams where 4 minutes is the baseline for their integration tests. So now we're talking 400 seconds, or just 68 actions per day. Now, I don't know about you, but if you've ever run 4-minute tests as part of your daily activities, you pulled away to email, to Reddit, to Twitter, or whatever, and then you come back and you're like, oh shit, 3 minutes have passed since the test finished. And it rots your brain. So now 11 minutes maybe is a more realistic feedback loop in that case, and so now I'm down to just 43 actions per day. And now 43 is a much smaller number than 480. But you know what's significant about that? We found it. The 10x developer. So a few seconds here and there, they really start to add up. And I encourage everyone, buy a stopwatch if you have to, profile your productivity and measure where your time goes every day and optimize for any waste in your workflow. Like if you want to learn how to program really fast, then you should be looking at your feedback loops. How fast can you learn whether the code that you wrote worked or didn't work? And really, really tighten that up. Because if you're getting 960 a day, you're going to be learning a lot faster than somebody who can only get 100 per day. If it's still too slow, if you've got a big monolithic app and everything's just too crazy and knotted together, start implementing new features as separate modules or components outside of your application and get those working and iterate quickly and then integrate later. Last thing I want to talk about is my favorite, false negatives. What do I mean by false negatives? Well, what does it mean when you see your build fail? Most people respond, well, it means the code is broken. Nope, not usually, not quite. Because the follow-up question is, well, what file did you need to change to fix the build? Well, usually we have to update a test to fix it. Oh, so a test was broken, not the code. This gets to a definition of what a true negative and a false negative is. A true negative, a red build in that case means that the code was actually broken, and the response is you got to go fix your code. When we talk about testing with our managers, they think this is every build failure because they think that the purpose of tests is to prevent bugs from reaching production out of your build. A false negative, though, simply a red means unfinished. We missed a test somewhere. We forgot to update a test or a configuration to our build, and the result is we have to fix the test. So true negatives, though, they reinforce the value of our tests, right? Like they make us feel like, oh, good, that would have been a production bug. I'm glad we had a test for that. Unfortunately, in real life, they are depressingly rare. I can count on one hand the number that I've seen in the last few months. Bummer. False negatives have this terrible effect, meanwhile, of eroding our confidence in our tests. They're the reason why your CI build probably bums your team out, because it starts to feel like a chore. You start to feel like you're a slave to your test suite. The top causes for false negative test failures, redundant coverage. Like you changed the local test of the thing that you changed and the thing, but you forgot, like, oh, I've got all these other tests that call through to that thing too, and I didn't think to update those tests. And slow test suites, like if you're not able to run easily all the tests locally every time you push, then it's very easy to let things escape up to the build. Usually, i.e., lots of integration tests, teams will see the integration tests slow them down, and then the abundance of false negative build failures will slow them down even more. So I track whether every build failure is a false or a true negative. If this is a new concept to you, I encourage you to take a log of that and then measure how much time it takes to fix everything. Because you can use that failure data to analyze any root causes, any problems in your build, and justify investing in different improvements that you can make in a broad-based way. So there you have it. We won. We got through all 3 phases. If you feel like this talk was a bummer because it was about stuff we hate about our tests, just remember that no matter how bad your tests are, I probably hate AppleWorks more than you hate your tests. Seriously. I come from an agency called TestDouble. We are a software consultancy. So if like your team is looking to hire senior developers, or if it's got some systemic issues, rather than hire somebody, work with us instead. Like our consultants are awesome. They love pair programming and working alongside client engineers, and we just try to help make software a better place for everybody. If this message particularly resonated with you and you want to help fix the way the world writes software, consider joining us. You can reach me at join@testdouble.com or see me all day. I've got lots of stickers and business cards if anyone wants a TV sticker. But most importantly, thank you so much for sharing your precious time with me. It really means a lot.